Thanks, Anthony.
Problem. So this is this second session, which I often title using citation indicators wisely. We have a larger issue at hand across not only the nation but across the globe, in that citation metrics are often used, well, two ways irresponsibly. One, they're often being used by people who don't really even know where the numbers are coming from or how they're counted, which is not a problem of the people themselves. They're just being given it. And we do see that when we're getting questions that are comparing Google Scholar accounts to our own data. Obviously, there's just a lack of understanding of how that data is captured and how that data is cleaned and that sort of thing. I totally understand that from a researcher's perspective. I totally understand that it's not their job to really understand the data and how it's captured, but using it responsibly is important when they start to cite numbers around their own body of work or a department's body of work or an institution's body of work or whatever it might be. The other thing, we're finding funding agencies, and it's ingrained in our culture to present certain numbers or metrics on our own research or any sorts of research that may not necessarily be the best metrics to be using. I often like to use the example where I'll say, look, someone's published a paper here and they've been cited 50 times and the impact factor of the journal that they published in is 5. Now, is that good or bad? And I like to ask people whether that's something that is good or bad. And it's really nothing unless you actually look at those numbers and start to run comparisons. And we have already touched on this in the first session, but where we're starting to run normalized metrics that compare those numbers. An impact factor of 5 and a citation count of 50. Is that really good? Well, if I published that paper, a couple of years ago in a mathematical journal and it was a maths paper, yes, that's probably a really very good paper, really very impactful, and has obviously garnered a lot of interest very, very quickly. However, if I published that paper 15 years ago in a biochemistry journal, and at the time that journal had an impact factor of 0.5, maybe that's not necessarily a reasonable way of looking at that paper, or it's not even that paper hasn't necessarily made the impact that one would expect when publishing a paper in that category 15 years ago. So it really does need to be put in context, and so that's what I'm going to try to do here. The other thing that's often misunderstood is the way that bibliometric data works and how it looks. For this one, I'm going to jump across just very quickly into our third link across the top here, which is journal citation reports. I'm just going to open up a new tab. You guys have access to all of this as well. As a matter of fact, you guys have access to everything here at RMIT, so feel free to click and play. Here, I'm going to look at, for starters, journal citation reports is actually our journal reporting tool. So you can pull out any metric you may ever want on a journal. Obviously, people talk about impact factors a lot, but they're often misused. And ultimately, if I'm looking at a single paper, and let's do this. For example, if I'll browse by category here, and this will actually pull up now all the categories, Web of Science categories that we map journals to. If I click on category, I'm now ordering obviously alphabetically. If I click on number of journals, you'll see that the biggest categories here. So economics is our biggest category by total number of journals. There's 363 journals which our company considers to be economics journals, and so are matched to that category. Here, though, let me alphabetize these and actually pull out a specific category here. And it can really be any. The distributions that we're seeing in any of these categories are all very much the same. I am going to pull out robotics as the example. If I click on the category here, I get an overview of the category itself, the number of journals that has been mapped to robotics each year, the total number of articles published in robotics each year as an entire category. If I go back to robotics here, I'm going to click on the category again and just alphabetize that and scroll down. If I go back to robotics and click on the 26, I'll actually get a list of the 26 journals that are mapped to that specific category, and the the metrics around each one of those journals. So if I was in robotics, for example, I'm now getting the robotics journals ordered by impact factor. There's 26 in there, obviously, and the top 25% here would be considered Q1 journals. So if my maths is any good, 13, 7. So the top 7 odd journals here will be Q1 journals. The next 6 or 7 will be Q2 journals, and so on and so forth, based in the field of robotics. If I click on a journal title here, you can actually pull up a profile of any journal in here. And this is where I really want to get to my take-home message. Every single journal, every single distribution for a journal will look exactly the same. I'm looking at the Journal of Robotics. I've actually never pulled up this page before in my life, but I know exactly how it's going to look. There's very, very few articles that are cited a lot of times, and a lot of articles that are cited very, very few times. And we always see a decaying exponential like that in any field, in any journal. When calculating the impact factor of this journal in the last 2 years, so 2016, 2017, 119 articles were published in this journal, and in the year 2018, they were cited a total of 517 times. We divide those two numbers by each other to get an impact factor of 4.3. Great. If I'm looking at these articles, though, the majority of articles here published in this journal in those impact factor years have been cited 0, 1, 2, or 3 or 4 times, a lot less than the impact factor of that journal. So looking at the number of citations each article has received, it's a lot less than you would expect. There's a couple of articles here that have been cited 24 or 25 times. Great. And ultimately, it's those 2 articles or 3 articles, there might be 2, 3, or 4 articles there, that are driving the impact factor, and they're listed underneath this distribution. So this one here has been cited 25 times, 24 times, 18 and 18. And those 4 articles, even if we just consider the citations that those 4 articles have received in that impact factor year, that's making up a quarter of the citations or something like that. That are contributing to this journal's impact factor. So ultimately, 4 out of the 100 odd articles published in this journal are driving that impact factor. So at an article level, the impact factor is really a terrible metric to be using when classifying good or bad or impactful research. We can get some other journal level metrics which are useful at a journal level. If we're looking at kind of the impact that the journal itself is having, great, the impact factor might be a great way of talking about it. It's still, the other thing I should say to this metric is that it's an average. Yes, I will. Sorry, I haven't magnified this particular page. I apologize. I moved across the browser. I'll pop that a little bit bigger. The journal impact factor is an average. So that average is 4, which would sit in here. The average for an article in this journal is 2 citations, and the average for a review is 18 citations. There's always a disparity there, and really the reviews are actually driving the impact factor of this journal. And so even that, an average looking at a decaying exponential like that is the worst way of actually looking at that sort of distribution. And it's just ingrained in the culture of people looking at bibliometric data that they will use the impact factor, which is a bit of a shame. So do be wary when you're using those numbers. You can pull up this sort of page on any journal. If you scroll through our journal citation reports, you can get a journal profile page that looks a lot like this and try to understand how that journal is performing and what it's publishing and all that sort of thing. Going back from here, just back into InCites itself, we start to pull out and start to use those distributions in ways that are much more reasonable and are much more wise when considering citation metrics. So, for example, if I wanted to pull out organizations, I'm going to jump into the organizations tab, and I'm going to start by doing what I always do, which is clear those filters, because I was doing something there. Whatever I was doing last has kind of remained. In the organizations tab, you're getting a list of all the organizations globally that we enhance, starting with the University of California system. Fine has produced most of the documents. When ordering by total number of documents, it appears at the top of the list. In any one of our explorers, we can actually drill into this data and start to look at something. I'm going to make this a little bit more reasonable. I'm only going to look at academic organizations, not other research organizations, and I'm going to take location, and I'm going to filter by just Australia. So really, I'm only looking at Australian universities, and I might even go one step further and say RMIT, I might take, let's take Royal out and just pin this one to the top. So we're always looking at, no matter what our filter or what we're ordering by here, RMIT will always sit at the top. Now, these metrics are a little bit better. Total volume of documents, fine. Total number of citations, fine. When RMIT publishes in a specific category in a specific year, they're getting cited 1.2 times more than the global average when looking at those averages for the same publications published in the same category and the same year. The percentage of documents in the top 1 and 10% is also normalized across the category and year of each publication. So we're really binning publications into their specific peer groups to run those comparisons. We can also run comparisons like international collaboration if we wanted to look at RMIT. And so let's look at that metric, for example. I'm going to do a bar graph here, and I'm going to look at international collaborations. That's RMIT, which is at the top of the list. Let's compare it to the top kind of 15 universities in Australia. RMIT on 40% of its documents has an international collaborator. Let's actually make this a little bit more recent. I'm just going to look at the last kind of 10 years, I guess, so publications of 2010 onwards. RMIT then has an international collaboration on 47.5% of its publications, 47.5% of its publications. Griffith University only 44.5%, whereas Curtin University 53.5%. So you can start to make direct comparisons between organisations that are fair and meaningful for a whole bunch of different metrics like percentage of international collaborations or category normalized citation impact or percentage of documents in the top 10% or whatever you like. So those impact measures are not necessarily averages, but rather breaking that exponentially decaying distribution up. Good start. How is this useful to most people on the call? Let's say you wanted to break down your own research area. So let's say you wanted to look at which organisations in Australia or globally are producing content in the research area that you're specifically interested in. Now, you can run custom analyses and look at those sort of impact measures at a very, very specific topic. I obviously can't do everyone on the call. I imagine that everyone on the call is in different sort of areas of research, but I can use whatever area you might like here. You can even, recently this morning, actually, I was running a search on space technology. So I could even use something like that, something to the effect of, what was it? Hypersensing. So let's do that. Or multi-sense that. So again, I'm not an expert in this area of research. If you're an expert in whatever area of research, you can construct a topic search around any sort of area you like. Again, the Boolean string operators work as you would expect them to. ORs will look at things that are mutually exclusive. Mutually exclusive of one another. So this is pulling out any publication, running a topic search which has hypersense or multisense somewhere in the title, abstract, or keywords of a publication. If I was to use an AND operator there, it would look for both those terms appearing somewhere in the title and abstract. You can make those topic searches as complicated as you like to really drill into the area of research that you might be interested in. I have this, which is looking at hypersensitive or hypersensing. I might actually even want to drill into that further to, I'm getting hypersensitive optical measuring here, which may be not what I'm interested in, but again, for point of demonstration, let's leave this. Now, any set in Web of Science, any topic search, any person search, any department search, whatever you're searching out, address line search, whatever search you're conducting, you can export a custom set to InCites and then drill into that. Obviously, this particular search here that I've constructed here, hypersense and multisense, is not a filter that can be applied in InCites, but it is a set that I can shift to InCites to then filter by this specific set of publications. One limitation to this, though, is that the data set that I'm shifting over can only be up to 50,000 documents big. So in this first case, I'm going to have to actually filter by maybe just what's been published in the last 10 years or something like that. Say, for example, I'm in this area of research and I just want to look for organizations that are performing well in this area of research globally, so that I can look for potential collaborators, or where my postdoc may want to be, or whatever I like. I can start to run an assessment at an organizational level or a regional level, or look at the journals that people are publishing this type of document in as well. So now I've just refined by the last 10 years, and I'm now looking at a set that is less than 50,000 big. And so I'm going to now export that set to InCites. This is a functionality that is only available if you have a login to Web of Science and InCites. And I'm going to do hypersense or multi and save that across. It will send me an email now saying you've saved 44,000 documents across into InCites. Where Web of Science actually updates daily with new data, InCites updates monthly with data, so it's a little bit lagged. So any documents that were published and indexed in the Web of Science in the last month may drop off that list. Now, however, if I jump over to InCites and jump back into my home screen, I will have a document set which I've named, whatever I've named it, which I can drill into. So let's say I wanted to look at the countries across the globe that are producing research in this specific area. I can jump into that and I can say, great, data set is hypersense or multisense. You can see actually some other examples of data sets that I have. Any user can have up to 20 data sets saved at any one time. Here I've run a search on climate change and refugia, where people are being made refugees by climate change. I've also run a couple of searches on the UN Sustainability Goals 14 and 15. For those of you who are familiar with the UN Sustainability Goals, there's 18 or 19 of them from memory, and they look to kind of solve some of the globe's bigger problems. And we can look at, for example, I think UN Sustainability Goal 14 is life below water, and there's a whole bunch of goals that the UN's laid out there that they would like to see. And I just constructed a topic search around that specific goal, and we can look at the organizations or the regions that are producing research that is contributing to the solutions that are required for that goal. So I can click on that. Let's actually use that as the example. I'm going to click on that. This was a much more complicated topic search, I guess, which used a very long string of search terms. And we're now looking at that data set. There would have been about 50,000 documents in this data set as well. And if I order by total number of documents, I'm looking at the regions in the globe that have produced most of this research and some impact measures as well. So the USA has contributed most of this research to this goal, followed by China, followed by Australia. So life below water, as you can imagine, a lot of Australian organisations are in aquamarine research. And so we're actually the third biggest producer by country of this content. We can also start to look at other interesting measures here, like our category normalized citation impact. Let's actually define that. I'm going to click on that 4,000 papers. This is everything that Australia has produced in this. So the top paper there is called Coral Reefs Under Rapid Climate Change and Ocean Acidification. It was published in the research area of ecology in the source title Science in 2007. Now, if I take every single paper published in ecology in 2007, and I run an average there, the average number of citations received by all those papers is 160 odd. This particular paper, however, has received almost 3,000 citations, which means it's been cited 18 times more than the average publication in that specific category in that specific year. So it has a category normalized citation impact of 18. The document under it, published in Nature, has been cited less times, but has been cited more times in comparison when you're comparing it to everything published in the same area of research in the same year of publication. So you'll notice this publication is actually performing 74 times better than expected with regards to the number of citations. So each one of those documents will get a category normalized citation impact. Next to it, the average across the globe will be 1, obviously, because we're normalizing to an average. So we expect it to be 1. When we're looking at Australia and all of its research in this specific area, its category normalized citation impact is 1.9. So it's being cited, or Australian research is being cited about twice as often as expected based on the year and area of research that Australians are publishing in here. You'll notice straight away that our CNCI there, or Australia's CNCI, is significantly better than a number of other countries there, but worse than some others. So we're performing a lot better than Brazil or India or Japan or China in this area of research, but not as well as countries like England or others. Again, we can make this a little bit more relevant if we wanted to. We can look at just the last kind of 6 or 7 years. Which will give us completely different numbers that maybe make our analysis a little bit more recent and a little bit more relevant. The cog next to name here on any browser can be used to select indicators. The default indicators are the ones that you're seeing there under selected indicators. If I click on browse indicators, I can actually add as many metrics or numbers as I want to my data set that allow for different types of analyses or comparisons to be made. So let me just add some that are commonly used. Again, you can explore those and you might have specific entities there that you're interested in. Here, we're looking at percentage of documents in Q1 journals, percentage of documents in the top 1 or 10%, and we can now do what is an ordering by those. If we wanted to order by the countries that collaborate most often internationally in this area of research, you'll get a bunch of small ones that are always collaborating internationally. We can actually run a threshold here if we like, and say we actually want our institution or region to have produced at least, and I might click on that number and just change that to at least a minimum of 1,000 documents. And we're now looking at just the countries that have produced more than 1,000 documents in this and ordering by total number of international collaborations. England and the UK collaborate most often internationally in this area, and Australia is actually now 8th on the list. We can do the same with kind of percentage of documents in Q1 journals and start to look at impact measures, which are much more fair to compare regions by than just total volume, as obviously the volume will likely be altered by the size of the nation or the size of the research population of that nation. Further to that, if we wanted to drill into this, let's say this is your area of research, we can go into InCites and say organizations and do an organizational comparison. I'm now looking at exactly the same data set, but I'm looking at organizations that have produced most of this work, and I'm now ordering by total number of documents. If I'm only interested in local organizations, again, I can filter by location, and because we're looking at marine research, for example, we're going to likely get, so yeah, JCU, University of Tasmania, CSIRO are the Australian organisations that have produced most of this research, and all of them will have a category normalised citation impact above the global average. If we construct a benchmark and baseline for all items, we're now looking at an Australian average up the top there, and we can see the institutions that are doing better than the Australian average as well, which is well above the global average. So we can run two comparisons there. Let's say I wanted to go even further and look into people that are producing this content. If I jump into InCites and click on researchers, I'm still in this kind of aquamarine type area. Again, I might want to make this analysis a little bit more relevant. So I just want to look at the last kind of 5, 10, however many years. I'm going to do that. And then I'm going to look at the people that are producing content in this by total number of documents, and I'm straight away, I haven't even thrown the Australian filter on yet, and the top people here are obviously based currently in Australia, and there's a number affiliating themselves to other organizations. Do be wary when you're in the People Explorer here. You might find that some names are duplicated, and that's simply because people may be affiliating themselves with multiple organizations. So, and they may even have documents that are affiliating, the same document that they're affiliating themselves to multiple organizations on. So if I search out Monday here, you might get different variants of Philip's name here, as well as other organizations that he's affiliating himself to. In this case, it's only JCU that is affiliating himself to, but he's actually popped up under a couple of different name variants, or he hasn't affiliated himself with any organization on a paper. So we can pin those to the top and then run a baseline and a benchmark for all pinned items there, and then get rid of that specific filter. And we're now looking at a deduped count. Do note there that 62 plus 3 plus 2 is not 66. It's a deduplicated count of his publications, and we're looking at his entire contribution to what is the UN's sustainability goal number 14, or whatever the topic search that I created at the start is here, in comparison to some other people globally that are contributing to that. So this is a great way to look at people or institutions or others that are producing content in your specific area of research, and how well they're performing with regards to not only volume measures like total number of outputs or total number of citations, or even other things that are kind of volume measures or very directly related to or directly I guess correlated to volume measures, but also able to create or look at impact measures, which will be correlated to one another in one way, but very, very separate from what are volume measures like total number of publications or total number of citations that you're getting out of a Google Scholar profile or a basic bibliometric search in Web of Science. H-index is another one which I want to mention. A H-index I can produce here. I can add this if I browse indicators. I think one of my impact measures is a H-index. I can add this to this level of data, but ultimately a H-index will be very, very closely correlated. I'm just going to get rid of those pinned items and look at what we have is the original set. So from top down, you'll notice that as volume of publications drops, H-index tends to drop as well. H-index really is just a volume indicator. I understand how it's calculated, but it is very, very closely correlated to total volume of publication, in which case you need to be very, very careful. It's not an indicator that can be used very, very usefully to compare professors to early career researchers or people in different subject areas. A professor publishing in mathematics, the H-index will look very, very different to someone publishing in biochemistry, for instance. It's largely a volume measure or volume metric, and not necessarily an apple-to-apple comparison where when looking at kind of category normalized citation impact or percentage of documents in the top 10%, the different categories and different lifespans of a researcher have been considered and normalized too. Good. I hope that's helpful. I've dived into a specific area of research, and I'm pulling out metrics on a researcher or an institution, and I think I've talked around a lot of those metrics that I might like to have talked around there. I'm just checking the chat box. There's a quick one just on a researcher report in Web of Science, Research ID. It says there's no results available. I think I mentioned it at the very, very start of the first session. Do be wary when you're using in reports. You can use any of these reports. So a researcher report will actually produce a report on an individual. If you have just created or have created your researcher ID or ORCID ID in the last couple of weeks, it does take a couple of weeks for data to be ingested into Web of Science, and then maybe another month potentially to be ingested into InCites. InCites is a monthly update, so let's actually have a look at it. At the bottom of any Explorer, you'll get a timestamp. I should have mentioned this right at the very, very start. You'll notice the timestamp is actually overnight. InCites data updated last on the 28th of April, which was overnight, and includes everything indexed in the Web of Science through to March the 31st. So if I created my researcher ID or ORCID ID on the 1st of March, it may have then taken a couple of weeks to be indexed in Web of Science, and then InCites data has actually only just caught up with it overnight. So it will take somewhere between 2 to 6 weeks for an ORCID ID or a researcher ID to be ingested into this. So it's not an instantaneous process, so do be wary if you're filtering by one of those things. It's worth getting one set up now for next time you come to writing a grant though. Or a promotional application or whatever it might be. So I've done a specific topic search there. I also wanted to, how do we, so this is a really very good question as well. I was just about to address this question, so thank you very much for throwing it in the chat box. How do we benchmark, say, with other researchers at a particular level within a particular organization, say for promotional purposes? This is one that often comes up, as it's something that's expected in a lot of promotional applications now, is that researchers want to benchmark against others. Now, I sort of touched on this in the specific area of research there that I did, the UN Sustainability Goal. I guess what I'm doing here is comparing researchers globally to other researchers in this very, very specific area of research, which is aquamarine sciences or whatever I searched by. I can also filter by Australia here or a specific organisation. If I wanted to compare researchers across Australia, I'm now going to only be looking at people who affiliate themselves with an Australian organisation. I can even go one step further and filter by an organisation here and filter by CSIRO and look at only researchers at CSIRO and compare them in their contribution to aquamarine sciences in the last, I think I've still filtered by just the last 7 years. If I was to extend this out to the whole data set, obviously these numbers would change and you get more comprehensive data, and you can do that however you like. Do note though, this is not capturing all these researchers' work because I have filtered up front to start off with by a topic search. So if, for example, Alistair was producing content not only in the marine sciences but also in engineering, for example, or something else, maybe those documents aren't captured in the original topic search that I created. So if you do want to do what Ravi in the chat box is asking for, and look at an entire person's history and look at, let's say a whole bunch of C-level researchers, we might go back to the whole InCites data set. I'm going to turn ESCI on. ESCI is Emerging Sources Citation Index, which is an additional 7,000 journals and content that is indexed in those 7,000 journals. So if you do want additional content there, you can just tick that on. I'm going to look at the last 10 years, and I'm just going to compare researchers to each other in the last 10 years. And then we can take person, name, or ID and start to throw people in. Now, I've thrown a person in here that's the last analysis that I was doing was actually on Yang Lu here, who asked specific questions around their content. Let's pretend like I wanted to compare myself to Yang, who's at a specific or a very, very similar point in their career to myself. I can then throw in multiple researcher IDs, and I've got two metrics there which are comparing each other's to them. We're comparing each other to or metrics on each other's research directly here. You can add as many researcher IDs or ORCID IDs as you like to this analysis if you know that they are in a similar stage. I might actually browse researchers here and look for other researchers at the University of Sydney or in Australia. So I'm going to type in the University of Sydney. Actually, I'll just type in Sydney, might be a better place to start. And I'm now going to look at people, and I'm going to get rid of these filters. And I've now got people at the University of Sydney with a number of publications attached to their research ID. I could scroll down here and find people who are in a similar stage of their career that have 40 odd publications, somewhere between 40 and 60 odd publications next to their name, and use them to filter them out. Or I might know the people that are on my level or in the similar sort of areas of of chemistry here that I might want to compare myself to, and I can simply use those and add as many of those as I like to my InCites filter. If I go in here, I'm actually going to just pick a whole bunch at random rather than picking them out, but I understand where your query comes from here. I'm going to add I've added 5 or 4 other research IDs to the analysis than my own, and I'm now comparing myself directly to 4 other people. Again, I can add as many metrics as I like to this, so I can browse these indicators and look at productivity indicators and suggest that, you know, I either publish more with international organizations, or I collaborate more with industry, or I publish more open access content, or any one of those things. Again, I encourage you to browse that content. And if I was to compare myself to Yang, who is sitting in the office next to me, I would say I publish more often in Q1 journals. I might have a smaller number of publications and a smaller number of citations, but when I publish, I get cited in a specific category in a specific year. I get cited more often than Yang. Yang's H index is bigger than mine, fine, but ignoring that, I publish more often in Q1 journals. A higher percentage of my documents are in the top 1%. A higher percentage of my documents are in the top 10%. I collaborate more with industry, or more often with industry, and more often internationally. And so maybe there I'm making a case for myself for promotion over Yang. So I hope that answers your question there. That was in the chat box earlier. There is another really very good question here around what is the difference of the scope of research metrics between Web of Science and Scopus. Really good question. The metrics that you're seeing here are often very, very similarly calculated in Scopus. So Elsevier, we talked to it in the first session, is one of the other providers of what is a true citation network, a true citation database. And so they are able to calculate these normalized metrics as well. I think you'll find that things like category normalized citation impact is just renamed in the Elsevier product or of Scopus or Cival. It will be called field weighted citation impact or something like that. They obviously don't have Q1 journals or Q2 journals. That's kind of specific or unique to our platform. Percentage of documents in the top 1 or 10%, I think they may do a similar sort of analysis there with regards to, you know, percentage of documents in the top 5 or 25% when normalized to the category and year. You can get out in here, if I click on any one of these numbers, I can jump into an article level distribution. So I'm clicking on my own just to pull out my own numbers here. And let's actually run this export. I just want to show the usefulness of this with regards to the metrics that are produced. I've exported this at an article level, and this is standard. You can't actually change the metrics that are coming out at an article level in one of these InCites reports. However, the metrics that come out are very, very useful. All this stuff, I think I talked to earlier, is the static stuff. I'm just going to put that in red. It's the stuff that's not changing on my content. The stuff that really is where I've published, what I've published, and what years I've published it in. This stuff over here is the stuff that's dynamic and constantly changing, potentially changing with every InCites update. So here, I've got category expected and journal expected number of citations for my documents. So my top document here has been cited 173 times. But really, if I compare that to everything else published in this journal in the same year, the expected number of citations is 150. So that article really, although it's my most cited article, it's basically being cited as often as one would expect based on the year and journal that I'm publishing it in, and probably twice as often based on the year and category that I'm publishing in. So when I'm comparing it to those expected averages there, it's not really performing all that well. If I order my documents rather by category normalized citation impact or percentile, I might sort and filter smallest to largest in the percentile column. I'm now looking at documents that aren't necessarily my most cited documents. If I look at these ones here, some of them haven't been cited too much at all, but they are in the top 10% or even the top 7% when I compare them to category and year, other documents published in the same category and year. So if I'm really wanting to pull out my top 5 documents, I'm probably pulling those ones out there rather than my most cited. And if I order now back by my most cited, largest to smallest, they're not necessarily my most cited documents, you'll notice there. So do be wary of that, and do make cases for some of those documents there that are performing particularly well, that I've, like you or your body of work. You'll notice that these ones are all recent publications as well. And just because they don't have a big site count next to them doesn't necessarily mean they haven't garnered a lot of interest very, very quickly based on where they're being published. So I hope that helps there. I think that's answered the question. There's a question from Robin in the chat, which they've missed how to get H-index and percentage of documents in Q1 journals. I'll quickly take you through that. I might have scanned over that too quickly. So if I'm in any Explorer in InCites, I'm going to jump actually all the way back to the home page. Any one of these Explorers, I haven't done a breakdown by journal or funding agency on my work. I think I've touched on all the others though. But if I jump into at a researcher level or any one of these Explorers, the beauty of these Explorers is they remain exactly as you left them. So you'll notice that this analysis hasn't changed. I'm still looking at a comparison of myself against these 4 other researchers. To get all these metrics, or to customize the metrics that you're seeing in this table, it's a cog. Hit the cog next to name, and you'll see selected indicators. These are the ones that I currently have in my table. I can remove them if I don't want them anymore. So say I'm not interested in percentage of documents that are open access or percentage of industrial collaboration, I can remove them. If I click on the browse indicators over in the top right here, I can get impact measures or productivity measures, or whatever you like there. You can pick and choose the indicators that you might like to see on your own body of work or any body of work that you're analysing in here. And I encourage you to just select as many as you like, and they'll then appear in your table. Citation impact is just the average number of citations per paper. If I wanted to run that comparison in here, I could do that. The journal normalized citation impact is a journal comparison where I'm normalizing to journal rather than the category. So if I add those and click done, you'll notice now on my analysis, I'm running that comparison. And so Yang's documents get cited more often on average than mine do. But when I publish in a specific journal in a specific year, I get cited more often than expected, and more often than Yang does when I run those comparisons. So I hope that answers your question there, Robin. Really good question, and thank you very much for it. I am conscious of time. We have about 15 minutes left. I think I've probably covered the content that I wanted to cover in terms of using metrics wisely. Is there any questions before we stop at I think we're supposed to be stopping at 12:45 according to my diary. Is there anything people want to see on a research area or on a person analysis, or any questions around any of our data? And if not, I might give you your 15 minutes back.
That's great. Anthony, does anyone have any questions? You can pop them into the chat, but if you could also turn on your mic and ask it directly if you wanted to at this stage. But otherwise, we've got I'll be sending out an email either this afternoon or tomorrow morning with a link to this recording, and we'll have links to where to contact details, so you can contact Anthony or contact the library for any support using any of these tools, and some online self-help guides as well that I think we've posted a bit in the chat area for those guides, but it's probably gotten lost in all the chats, so I'll compile it all into one nice comprehensive email.
Yes, one other thing I should have pointed out, if you do want definitions of any of those metrics that I've talked to, I don't think I went through and individually defined each one, but if you scroll up to the top and you click on help in InCites, there is an indicators handbook here, which will go through one by one and define each of the indicators or metrics that I talked about. So you can kind of use that to define and really understand how you're using it. It's there. So I've just clicked on help and I've just clicked on indicators handbook there. Each one of these indicators and calculations down the left-hand side can be clicked on and just kind of understood how I've calculated that and how that looks. So percentage of documents in the top 1%, if I click on that, I've got a definition there around that indicator, and they're all there really. There's also a hard copy PDF. If I just could jump back up in the indicators handbook, you can download the InCites hard copy PDF of the printable version of the handbook from that site, and it will go through one by one and define each of those. I hope that's useful. Please go into there to get definitions, but if there's anything further that's not covered in there that you're still not understanding, like Tristan said, reach out to one of us.
That's great, Anthony. I didn't know that existed, that handbook, so I'll be having a look at that this afternoon for sure. That's great.
The PDF looks a little bit like this, and it will really go. It's a lengthy enough document that it goes through and defines each one of those indicators. There is a little bit of maths in here as well. I don't want to scare anyone off, but obviously a lot of our indicators are calculations. So there's a few little calculations here. I promise you that the math isn't too difficult. And shouldn't scare anyone away, but yeah, if it does, yeah, like I say, reach out. That's the example distributions of what I talked to in the start of the second session are there as well, just to give you an idea of how we're calculating percentage of documents in the top 1 or 10%, or all those means and where means or averages should be used and where they should be used with some caution. So yeah, it's really very useful. So I hope that's helpful, Tristan, and to the rest of the group.